Welcome back to the Scotti-BYTE channel, and this is Scott. So if you've just gotten started with your home lab or you're wanting to add a new Homelab server, there's a lot of things that you can run into. And so I thought I was going to give a specific example of a couple of servers that I recently added here and some of the things that I ran into in the process of adding them to my home lab. So I'm going to call this one Homelab Servers 101. So small form factor mini PCs make great choices for Homelab servers. And I did a video a while back entitled Cheap Self-Hosting Server. And of course, I like to use containerization on the servers. And so I did a video also entitled LXD Containers 101 and Incus Containers step-by-step. And then I think there's also a LXD Containers step-by-step. So containerization really optimizes your use of a Homelab server. And if that Homelab server is a mini PC, all the better. So small form factor PCs take less space, they use less power, and they generate less heat. And so most mini PCs are sold with Windows pre-installed. And that can be a problem sometimes because trying to get Linux onto those when Windows has been on and secure boot is set, that can be trying, let's say. So any modern Linux makes a good choice since it will optimize resources when used as an Incus or LXD server, providing virtual containers, as I mentioned earlier. And more memory and better networking options are the priority rather than a faster CPU. So you don't really need necessarily a faster CPU. More cores, more memory is usually a better thing. And then fast storage and specifically NVMe should be the priority after more memory, because that really allows your containers to be much more responsive. And in this video, I will mention key considerations when configuring a small form factor PC as a Homelab server. So here we've got a picture of a Homelab server or actually two Homelab servers. One is a small form factor unit, and the other is a 1U unit. And yes, this does come with rack ears. Each one of these units cost about $300 a piece, and that's without any memory or storage configured. I want to thank my subscriber Calvin for providing these particular servers for my home lab in order to have a demonstration environment. And in fact, I've named them Demo-1 and Demo-2. And as you can see from the picture, this one here on the top is a small form factor type unit, mini PC type unit. And the unit on the bottom is a 1U rack unit. And yes, it comes with rack ears. It just are not pictured here. So both of these have exactly the same motherboard and exactly the same peripherals. They are in fact the same machine. The main difference is that the 1U unit has a fan mounted on the bottom, and it also has an internal power supply with the addition or possibility of using an external power supply. Whereas the one here on the top, the small form factor unit, is a fanless unit, and it has external power supply. The maker of these systems is a company by the name of Quotum, Q-O-T-O-M, and the first thing you notice from these pictures is that there's quite a bit of networking options available. And specifically, we have 5 2.5 gigabit NICs, and we have 4 SFP plus ports, which can use fiber or copper modules up to 10 gigabits. The primary use case for these units is to run pfSense And the reason for that, again, is because they have a lot of network interfaces. This isn't a particularly fast machine. It's based on an Intel Atom system on a chip, and it has 8 cores, but you're not going to be running any video games on this. That being said, it does make a pretty decent Incus or LXD server. Let's take a look at the specifications of the Quotum Q20331G9. First of all, as I mentioned earlier, it is an Intel Atom system on a chip with 8 cores running at 2.4 gigahertz with a 16 meg cache. And it's shipped with no memory or storage, so it is assumed you will configure your own memory and storage. And then it has 5 Intel i226V 2.5 gigabit LAN adapters, and it has 4 Intel X553 10 gigabit SFP plus modules. And then there are 2 NVMe's, which are the 2280 form factor, and then it has an internal SATA controller, and then not only that, it actually has an SFF 8087 external port to where you can connect an external SAS array. But my recommendation is to use a SAS to SATA converter and to configure external SATA drives if you have an external SATA enclosure in order to expand the storage greatly. And then it has maximum memory of 2 memory slots, each of which can accept a 32 gigabyte DDR4 operating at only 2400 megahertz, which is really pretty slow, and we're going to talk about that more in depth later. And then we have an RJ45 RS-232 serial console port, which most people probably will not use. And then we have a USB Type-C port, a USB 3.0 port, and a USB 2.0 port, and also, believe it or not, a nano SIM slot. And then we have VGA video. Yes, you heard me right. There is integrated VGA video on the motherboard. It's the old style blue connector. And again, it's got really low-end video. Presumably, the only reason you would use the video is to originally configure this machine, and then from that point on, you would connect to it as a server, and the intent would be that you would not have a keyboard or a display connected to it after you initially load it. Here's an up-close look at the rack mount 1U unit, and I just have it sitting on a shelf, and here you see that I have an RJ45 connector connected into one of the 2.5 gig ports, and I also have an SFP plus connection running back to an SFP module in one of my switches. Here's the main BIOS screen for the 1U unit, which by the way is the same BIOS screen for the small form factor unit. And it's noteworthy to point that when I got both of these systems, I originally configured them with a single 32 gigabyte memory stick, and I was unable to get them to post. I did not initially realize that the device was not posting, and instead I was blaming my video connections because I had an adapter that was running from the unit over to a newer style display. I discovered later, though, that I had not actually heard the post test come out, and that was most of the problem. Moving from the main screen to the advanced screen of the BIOS, the first option up here is the Trusted Computing option, which is where you enable or disable the option for the Trusted Platform Module or TPM settings. And so it has security device is enabled. I was never actually able to find the secure boot option, and in some BIOSes, the secure boot option is controlled by Windows and you can't necessarily enter it. But since there has been no Windows installed on this machine, I did not believe that that was an issue. If you have purchased a mini PC that does have Windows loaded on it, you will probably have to go through Windows in order to access the BIOS as opposed to going directly into the BIOS in order to disable Secure Boot to load another operating system such as the Linux variants that you would be using for a containerization project. The next area of interest in the BIOS under the advanced section is the network stack. And you can see here that the network stack is obviously enabled. And by default, it has a choice for either do not launch, UEFI, or legacy. And I want that set up as UEFI. My reasoning behind that is often I want to load a server from PXE. PXE is the pre-execution boot environment, and I've covered it on a video that I did for iVentoy, which is the network bootable version of the Ventoy utility, and I've also covered it on netboot.xyz, which is another PXE booting routine. Moving along to the next option here, we have the ability to configure UEFI for storage, and needless to say, we're going to be UEFI booting since we're going to have a GUID partition table, and we want to have the latest option to support larger storage devices, so we're not going to be using the legacy boot, which is master boot record. Further down in the advanced menu, you'll have a listing of your devices that you have configured. And here you can see that I have my Intel Ethernet i226-V, which is the controller. And we've got, as I mentioned earlier, 5 network interface devices for the Ethernet. And so if we go drill down into one of them, we can see its MAC address, which was actually listed on a previous screen. And it says it's using an Intel i226-V controller. Most systems with the i226-V Intel controller support Intel AMT, such as the Intel NUCs, and AMT is Intel's active management technology, and it's used for remote management of systems where you can power up a system, remotely load the system, or remotely access the BIOS. Despite the presence of the i226-V controller on this particular Intel Atom system, I could find no evidence in the BIOS for Intel AMT support, unfortunately. The next BIOS section after Advanced is Intel RC Setup, and the most significant thing to point out here is the North Bridge and South Bridge chipset configuration options. And so in the North Bridge chipset configuration option, we have several additional things that we need to take a look at. You'll notice that this particular system, I now have 64 gigs of memory indicated by 65536, and the memory frequency is DDR4 operating at 2400 megahertz. As I mentioned earlier on, initially I had a very difficult time getting the system to post, and one of the reasons for that was because of memory compatibility issues. As we scroll down the screen just a little bit further, you can see that there is a memory frequency option. So typical DDR4 laptop memory is usually going to be 3200 megahertz memory, as is featured here with this 2 by 32 gigabyte set. And this is what I tried in the system initially. However, if we go down into that level, you'll see that the fastest memory that this particular motherboard supports is 2400 megahertz memory. And unfortunately, the 3200 megahertz memory is not backwards compatible to 2400 megahertz. So DDR4 266 memory is backwards compatible to 2400 megahertz, unlike the 3200 megahertz memory, as I mentioned earlier. So I had to go with this option instead. Now that I had the correct memory and I inserted it into the machine, I still could not get a post test to occur. And one of the reasons for that is because it had become obvious that at the factory, the machine, although being shipped without memory, was initially tested with 2400 megahertz memory, yes, but with 16 gig sticks. And unfortunately, it could not seem to really overcome that. So the workaround was actually to pull the BIOS battery and to do a BIOS reset and then reinsert the battery, and I was able to configure the new memory pictured here. Headed on back to the BIOS, they also had an option for dual channel versus single channel memory. And dual channel was the default. The only reason you'd want to select single channel is if you used two memory chips that were unmatched in size. The other interesting fact that I discovered down here was that apparently this motherboard actually supports data center class ECC memory. And I don't see why you'd want to do that, because you're not going to gain a significant amount of speed, and ECC memory is far more expensive. In any case, although the crucial memory that I pictured on the previous page was non-registered memory, I still left the ECC support as enabled, and it did not affect the proper operation of the system. The next option in the BIOS that I wanted to take a look at under the Intel RC setup area is the Southbridge chipset configuration. And under that, they simply had the configuration for the various peripherals, SATA, USB, the PCI Express IP configuration, which is for the Pixie device boot, and then some other options as well. Moving from the Intel RC Setup tab all the way over to the Boot tab, I now have options for the boot order priority. After installing the operating system, I have as my boot option number 1 the Ubuntu operating system, which is running on one of the two installed NVMe drives. And then the other boot options are set up to do Pixie booting on the i226-V 2.5 gigabit NICs. I could have also supported Pixie booting over the 10 gigabit SFP Plus adapters if so desired. And if I go into the boot option, you'll see that I can go down here and set up Pixie booting for either IPv4 or IPv6. Since I disabled the IPv6 stack on this particular system, it only lists IPv4 boot options for both the i226 2.5 gigabit NICs and the X553, which is the 10 gigabit SFP Plus ports. The somewhat more challenging part about configuring these Quotum servers was the networking. And if I do an ifconfig here, you'll see that we have a Bridge 0 device, which is what I use in Incus Container step-by-step, and also in LXD Container step-by-step. And so Bridge 0 has the real address of this thing from an Incus server standpoint, and this is also my default route. And then that device really is pointing to ENO1, and ENO1 is one of the X553 controllers. They're named ENO1, ENO2, ENO3, and ENO4. So this is a 10 gig SFP plus port. And then we have ENP 5S0, 6S0, 7S0, and 8S0. And I configured 8S0 as the redundant Ethernet connection just to have another connector. And that was the RJ45 that we had pictured in the video earlier. When it came to configuring this particular system, let's move over to /etc/netplan. And let's do an ls. And I saved my original configuration file as 50-cloud init.save. And then here's the YAML file for the current configuration. So if I do a sudo nano on 50-cloud-init.yaml and type in my sudo password, we go into the nano editor. So as you'll notice here, I've configured ENP 8S0 and I have DHCP4 and DHCP6 equals to true, meaning that that adapter will get a DHCP address directly. ENO1, on the other hand, I don't want it to get an address because my intent is to go ahead and use this as the address for that main ENO1 bridge device, and then I have it using the parent interface of ENO1. So it's just like I do in Incus containers step by step. So the end effect of this is when I reboot, I don't have all of the other controllers listed when I do an ifconfig, and you may have noticed that when I did the ifconfig command here, I have bridge 0, ENO1, ENP 8S0, but you're not seeing ENO2, ENO3, ENO4, and ENP 4, 5, 6, and 7. And then, of course, we have the other controller devices out here, one for a container that's running, Incus BR0, which is the NAT bridge, and of course the loopback connector. Here we are over in my USW Pro 48 switch, where we have 4 SFP Plus connectors off to the right. And connector for port number 51, if we scroll down in the list, is the Demo 1 server, which has a 10 gigabit link. If I go ahead and click on it, it says it's active, and it says that it's set to 10 gigabits full duplex. And it is, in fact, working. After initially installing Ubuntu on the server and then making the SFP Plus connection, I was not getting a link. As a matter of fact, it would briefly negotiate and it would disconnect. And so I did a lot of reading on the net, and it pointed to the direction that probably what I needed to do was to not have it auto-negotiate, but to manually set the speed. As it turned out, that was not the issue at all. After not having the link come up properly, the next thing that I went ahead and did was to go and look at which SFP Plus connectors I was looking at. And you can see here that I was using iPolex 10 gigabit SFP Plus connectors. And these particular LC SFP modules have always worked fine for me in the past. And as a matter of fact, you see they're compatible with a whole range of systems. But sometimes SFP Plus modules are not always compatible. But these have always worked on my system. I've purchased them several times before and never had an issue. That being said, I still purchased another SFP Plus module to see if it would make any difference, and as it turned out, it did not. So the next thing that I did was I connected these SFP modules and the fiber cable that I had from one port on my switch to another port on my switch, and that correctly connected. The next thing that I did was I made a connection from the small form factor unit directly over to the 1U unit, and interestingly enough, that also connected and came online successfully. I performed a pretty large number of Google searches on the Quotum 20332G9, and I couldn't really find anything that addressed the problem with the SFP Plus ports. And interestingly enough, most people that buy this, as I said early on, use it for a pfSense server. Realize that the base operating system for the pfSense server appliance is not Linux, but it's FreeBSD, and FreeBSD is a Unix operating system. Most of the time in the Linux world, we take for granted that all of our device drivers that we need are compiled into the Linux kernel, and this was really no different. Unfortunately, the driver for the X553 that was compiled into the Linux kernel was not working in order to connect between a switch and one of these Atom-based machines. And if we look at this article by the Home Network guy that I eventually found on the internet, it says the primary issue that they had with the X553 SFP Plus interfaces is that they work fine when devices are connected directly to the SFP Plus interface, but they do not work when connected to a network switch. And that is apparently an issue that occurred once you go to the Linux 6.x kernel, which the majority of people are running today. It's a problem that will probably be fixed in the near future. That being said, this gentleman showed how you can go out and get Intel's newest driver and how you can download it and a process to incorporate it into your Linux system that happens to be running a Linux 6.x kernel. And the particular driver that's needed in Linux is the ixgbe driver, and that is what controls the X553 SFP Plus interfaces. After following the procedure in that article, which only seems to affect people that are running any Linux operating system on Atom processors, we were able to solve the problem with it not connecting. And as you can see here, we have a connection from the Quotum system over to the Unify switch. So the SFP Plus modules were not to blame after all, and it was simply an operating system kernel driver issue. The primary reason for making this video was to point out some of the problems that I ran into in regards to initially getting the system to post properly, what my process was to determine what the issues were, the compatibility with the memory, and the compatibility with the network device, which turned out to be a Linux kernel 6.x issue. And basically, if you implement a new system in your home lab and you're going to configure it from scratch, you may have issues with memory, you may have issues with storage, you may have issues with network connectivity. And the point is that if you go about trying to solve the problem methodically and you have due diligence, you will eventually get to a satisfactory result. So in summary, small form factor mini PCs draw a lot less power and generate less heat than desktops or surplus data center servers such as Dell PowerEdge servers or HP ProLiant servers that you might be tempted to buy off of eBay because of their great prices. And support for things like the Intel Active Management Technology, AMT, or Integrated Dell Remote Access, iDRAC, or the HP Integrated Lights Out, ILO, are great for remote management, but Pi KVMs are cheaper in the long run if what you require is BIOS level access and remote power control of a system. And in general, video is not needed for servers. Remote management is usually possible with SSH or a great open source project called Mesh Central. I personally use Remotely a lot of times, which is something I presented on the channel. And then you can use Lex Console for either management of LXD or Incus containers if your target device is intended to be a LXD or Incus server. And then understand your BIOS options, things like your network booting, PXE. Understand Secure Boot and where you set it and how you set it. And it's typically only needed for Windows, so you'll probably want to disable Secure Boot when you load a non-Windows operating system. And then Trusted Platform Module, which is largely used by Microsoft as well. And then the virtualization settings are those enabled on your particular motherboard so that you will be able to access virtualization from your installed operating system. And there many times are other options as well, some of which I covered in this video. So a small Linux server can provide a broad range of functions for your home lab. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.